two sides, we have weakened it, so it may break, because hard material is going to give you the discontinuous chips, means intermediate cutting, and this will give you the jerks and can damage your tool easily. Dear students, you may have heard about the high speed steel cutting tools, HSS. So these tools are very tough, very strong, can work at high speed, that's why named as like this. And we keep positive rake angle with those tools. This is the note which we have discussed, that less strength of positive rake angle can give the tool failure at high speeds as well as at intermittent cuts. Intermittent cuts are the cuts with jerks or you are varying the speed. Now come to the negative rake angle. As you can see in this diagram, when from the cutting edge towards the sink, your rake faces upward. It is not downward, it is upward. This is your negative rake angle. As from by comparing the two figures, you can see over here we have extra material. In positive rake angle, the rake face was below this line. So that much material we have removed in positive. But over here, this much extra material we have. So no doubt negative rake angle is going to give the more strength to our cutting tool. So where that extra strength is required? Yes, that is required for machining of brittle or hard materials. But we have to lose something. Something is that we are going to lose the sharpness of your cutting point and sharpness of your cutting edges. But we can compromise it for the machining of hard materials. And because of that lesser sharpness, we are going to get the lesser surface finish on the machine parts. More is the sharpness on the cutting edges, more is the surface finish. So as we have discussed, the tools used for machining of brittle or hard materials, the tools are of ceramic, diamond, CBN or cubic boron nitride. Those are made with negative rake angles. Dear students, as you know, hardness and toughness are reversal to one another. More is the hardness, lesser will be its toughness. So as they are hard, therefore they have more strength in under compression as compared to tension loads. Negative rake angle ranges from -5 to -10 degree for cemented carbide tools and from -5 to -15 degree for ceramic tools. Dear students, ceramics and carbides are brittle, hard, and therefore they are made with negative rake angle. And the value of negative rake angle vary depending upon the material you are going to machine. Because more angle you are going to give, the more machining cost for the manufacturing of cutting tool will be increased. So best way, if there is no requirement of cutting edges, but that can't be because we needed sharp cutting edges. Therefore a particular geometry we have to give. So that depends upon the particular type of application or requirement on the machine surface quality, the value of this cutting angle or rake angle we are going to give. Negative rake angles doesn't give us the good surface finish, but in one case they can give good finish. If we work with negative rake angle at higher speeds, because at higher speeds somewhat rubbing will be there and we will obtain the continuous cutting, not the intermittent but continuous cutting, that will give us the good surface finish. As more material is on the tool, therefore more thermal conductivity will be there, more area for the dissipation of heat, friction heat, therefore it will show better heat conductivity. Also, more is the material on the tool, greater is its strength. These are the benefits of negative rake angle. These are listed down as we are going to lose the sharpness of cutting edges, therefore tool will be more blunt. As material is more, that's why strength of cutting edges is more. They give more compression because we are going to press the tool against workpiece, so causes high compression. As sharpness is blunt, therefore more cutting forces has to apply. As the rake face comes into the contact of the workpiece first, therefore more friction will be there, and because of that friction more temperature will be produced. They are suitable for higher cutting speeds because at lower cutting speeds, at intermittent cutting, the brittle tool can break. And always remember, negative rake angle is suitable for only hard or brittle materials, while positive rake angle is suitable for ductile or soft materials. Now come to the third view of your cutting tool. Third view is your side view. In the side view, when you see at your tool from the side, like this arrow represents, this is the side, one side of your tool. The image will be like this. And in that image, three parameters are observed. Significant parameters are two. One is your side rake angle and another is your side relief angle. Dear students, if you see from the side, this side cutting edge will be seen like a point over here. This will be seen as a point. And this face, side flank, will be seen from this simple as this line, like this. This is the line of side flank. And when you see from the top, from this top view as this line, while this line, there are two lines, this single point as a side cutting edge angle, and this is the end point of your end cutting edge angle, and this will be this point. This will be seen as a point. So this rake face has taper on two sides. One is from end towards the shank, downward or upward, as we have seen in the rake angle, and second taper is given from side cutting edge angle to the end of your end cutting edge angle. So it is downward from this side cutting edge angle towards and end of the end cutting edge angle. So this rake face is like this. It is downward. It is downward on side also. If it is downward on the backward, that is positive rake angle. If this is downward on your side, from one side to another side, it is downward. So this is your side rake angle. Dear students, don't be confused. If your rake face is downward, downside, backwardly, it is your back rake angle. This is backward on the back side. If it is taper on the one side to another side, this is your side rake angle. So this side rake angle will be seen in the side view, as you can see. This side rake angle is given to facilitate the chip contact with your rake face. So chip motion or chip flow will be facilitated, and also it gives sharpness to the side cutting edge. If this material is removed, your side cutting edge will be sharp. Similarly, your sidewise angle is made by your side flank. This is your side flank, and between your rake face. So this signifies the material of tool, how much material is removed and what is left. This defines the strength of your tool. Third angle is your side relief or clearance angle. Dear students, as we have talked that this side cutting edge angle, and this is your side flank. So this side flank is taper from top to downward. As you can see through this yellow area, it is taper from top to down. It is taper inside. Why it is taper? To give the sharpness to this cutting edge. So we have made it as this much taper. So this is known as clearance because it avoids the rubbing of this face with the workpiece machined surface. So this is known as a clearance. We can't give much clearance because it will weaken the tool, and we can't keep it as nothing because this flank will rub with the workpiece. So an optimal value will be given. And that optimal value is your 6 to 10 degree only. So this is the side bench which we have discussed. This is the side rake which we have discussed, and for general purpose tools its value ranges up to 14 degree. So if we want to summarize and want to revise the terms of tool signature, these are the 7. And dear students, remember, we have to remember these terms in this sequence only, because if you merge or reverse the things, there is no significance of tool signature. Tool signature is only important when the terms are ordered properly. So this is the convenient and standardized way of representation. Let's speak about each term and repeat it. At the first place is your back rake angle. At the side place is your side rake angle. So dear students, as you can see, the both angles of rake angle are given on the first place. Rake face is on the top, so that's why both terms are on the top. Second is your end relief and side relief. The terms for relief angle both are given on third and fourth place. Fifth and sixth place is your end cutting edge angle and side cutting edge angle. So the pattern you can observe, as we don't name the end rake angle, there is no end rake angle, there is back rake angle. That's why term is back and side. Again at the third and fourth it is end relief and side relief. Then at fifth and sixth it is end cutting edge and side cutting edge angle. So pattern you can remember: back rake, side rake, end relief, side relief, end cutting edge angle and side cutting edge angle. At the seventh place is your nose radius. Dear students, the values shown in this figure are just for the example purpose, they are not the fixed value. Every tool will have their customized values, their different values. So this is just for the example purpose. This is again for the revision where all 7 parameters are seen in all 3 views. This is your front view, this is your top view, and this is your side view. Thank you, students. This is all about the tool signature and importance of tool parameters. These are the books you can refer for your study purposes and also used for the preparation of this PPT. Thank you very much.